Good afternoon. I am Mariam Gawich, Head of Information System Department at the Université Française d'Égypte, the French University in Egypt. Also, I am member in Laboratoire Interdisciplinaire de l'Université Française d'Égypte, Interdisciplinary Laboratory of French University in Egypt. And today I will present the research article entitled Emotion-Based Disaster Tweet Classification, Real or Fake. This article is presented by Dr. Alfonse, an associate professor at Computer Science Department, Université Française d'Égypte, and me. How can I? Okay. So these are the outline of our agenda. I will start with an introduction, motivation, objectives, related work, and I will present the proposed model for disaster tweet classification, experimental results, and I will end with conclusion and future work. So, according to the United Nations Office for Disaster Risk Reduction, a disaster is defined as a severe disturbance of a society or a community during a dangerous phenomena occurrence that provoke one, at least, of these consequences: human life loss, economic downturn, environmental loss, and material loss. Without no doubt, the social media platforms such as Facebook and Twitter play a crucial role in disaster management by providing the rapid dissemination of information. However, they also enable the spread of false information which can have negative consequences, such as panic among the citizens and investors, negative influence in public trust in the government, increase in crime rate, and so on. So the motivation of the research involved first eliminating the dissemination of fake disaster news on social media platforms, especially the tweets and the Facebook posts that provoke panic among people. And the second motivation is the raising awareness about the real disaster consequence. The objectives of the research is an automatic classifications providing just automatic classification for the new disaster tweets through the use of the machine learning algorithm, and highlighting the role of sentiment analysis or emotion analysis in improving the performance of machine learning algorithms to differentiate between the fake and the real disaster tweets. So, the previous approaches have proposed some methodologies that takes into account the introduction of machine learning algorithm and natural language processing. That's it. So all the above approaches ignore the use of sentiment analysis. And for the performance evaluation, they focus on one or two criteria, and some of them has no implementation to assess its performance. So we have here the maximum of accuracy is 79%. That's why we proposed a model that will boost the performance of the machine learning algorithm to determine the real or fake disaster tweets. So the proposed model involves mainly 5 phases: dataset preprocessing, emotion analysis extraction phase, feature selection, classification, and classification results label. In fact, the proposed model was implemented twice. The first implementation, it doesn't take into account the emotion analysis extraction phase, the sentiment analysis extraction phase. The second implementation takes into account the introduction of emotion analysis extraction phase. The model was implemented with Python language using Colab and R program for the sentiment analysis module. The data selection, the researcher have selected the disaster tweets provided by Kaggle, which is an accredited source, where 75% of the data set are used for the training and 25% for the testing. Concerning the data pre-processing phase, some of libraries are applied to clean the data set. So we have applied the TextBlob library for post-tagging, WordNet for word lemmatization, regex library for regular expression, and finally Panda library to drop the missing values that was existed in cells. For the emotion analysis extraction or the sentiment analysis extraction, the tweets are analyzed via the detection of 8 emotions. First emotion is the fear, anticipation, joy, anger, sadness, disgust, surprise, and trust. So the SuzuHat package, it is a Russian package, which is provided in our program, is used to apply the sentiment analysis on the disaster tweet dataset. In order to explain how the sentiment analysis work on the dataset, let's take this example of tweets. How could you leave when I gave you my all heart? This is symbol, okay? Symbol of the heart. So the SuzuHat assign the following score for each of the 8 emotions. 0 for anger, 0 for anticipation, 0 for disgust, 0 for fear, 0 for joy, 1 for sadness, and 1 for surprise, and 0 for trust. So the SuzuHat assign 1 for the negativity of this tweet and 0 for its positivity. For the feature extraction, the term frequency, inverse document frequency vectorizer is applied, as well as the count vectorizer to convert the numerical, the text dataset, the unstructured dataset, to numerical one. And after that, we have applied the classification algorithms such as multinomial naive Bayesian, logistic regression, decision tree, random forest, Gaussian boost, key nearest neighbors, stochastic Gaussian descent, multi-layer perceptron, linear SVC, support vector, bagging key nearest neighbor. So these are the experimental results that are generated from the SuzuHat package in the R program. So we have 2030 tweets that are considered as positive tweets, and 3,295 are considered as negative, and finally we have 2,628 are considered as neutral text tweets. After that, we have applied the machine learning algorithm first without the introduction of the previous results, okay, which is the emotion extraction, and we have the logistic regression has achieved the highest accuracy compared to other classifiers. And we apply all the performance criteria evaluation such as the precision, recall F1, and the accuracy. How I can back to the previous slide? Okay. Okay. So after applying the emotion analysis extraction phase, we have tried the classification algorithm, and we found a raise up in the accuracy level. So it is salient that emotion extraction analysis have boosted the accuracy, and the logistic regression has achieved also the highest accuracy. So when we compare with the proposed model and the previous model, we will find that the proposed model applies the natural language processing, emotion analysis or sentiment analysis, plus the use of machine learning. And its accuracy achieved 89%. And that's bring me to the conclusion. This researcher provides new classification models that consider emotion analysis during the classification process. And what really distinguishes the proposed model from others is the introduction of emotion extraction. So it helps to discover from the data new knowledge. Because when we use the R program and SUSU hat package, we extract from this data a new feature for the data. So the data was enriched with the new feature, which is called, in our case, tweet polarity. And really it has a positive impact on the performance of the classifier. But what it was ignored in this research, that we don't treat the emoticons. For example, when the symbol of heart, it is not treated by the natural language processing. So in future work, we try to apply a library such as Babel.net, which can treat these kinds of emoticons. And finally, thank you.